Hello, everyone, and welcome back to another MAT 170 concept session. Today, we're going to be looking at applying a negation to a function. My name is Nick, and I work with the ASU Tutoring Center, so let's go ahead and get started. So, given the question that we have on the screen, we're given two equations, right? F of x and g of x. Now, what they want us to do is first off determine the negative f of x and also the negative g of x. So we'll go ahead and do that first. Let me go ahead and write out. So we have negative f of x equals, and then really what we're going to do is just write a negative sign here, and then in parentheses, just write the original equation. So we have x plus 5. Now, what we have to do from here is kind of distribute this negative. So think of an equation, right? So I'll just write an example, z of x equals x squared plus 5x plus 6. Now, think of really like kind of what this involves is breaking down the equation. So the way you can kind of break down this equation, z of x, is into three chunks: the x squared, the 5x, and the 6. Now, if you notice, the reason why kind of like a good basis to split up your equation is to look at either the plus signs here or if there's a minus sign in the equation. Now, what you do is basically back to the original question here with the f of x is you essentially just multiply each part of the equation by -1. Okay, so it's going to be the same value that you have or the same variable, but it's going to potentially switch its signs. So from here, what we can do is basically multiply this -1 to x, and then multiply this -1 to 5, positive 5. Now what that'll give us is negative f of x equals negative x minus 5. Now, say if f of x was x minus 5, if we distributed this negative, we would have a negative times a negative, right? Which would result in that being positive. So it's really important that you remember that multiplying a negative by a negative results in a positive number, and that still applies in this case. So if we go ahead and look for the g of x, we'll go ahead and just do the same exact thing. So we have negative g of x, put our negative sign, and then in parentheses, we have x squared plus 4. And then what we can do is distribute that negative like we did for f of x. Boop, and then there we go. So then we'll have negative x squared minus 4. Perfect. Okay, now from here what we're going to do is graph both of the functions and then kind of look at the relationship between a regular function and then the negation of that function. So we'll go ahead and start with f of x over here first. So I'm going to graph f of x first. So we have 1, 2, 3, 4, 5. It's going to look something like that. Apologies if it's not perfect. And then we have negative x minus 5. So from there, we'll go down 5 in the negative direction. And then remember, because we have that negative x, that means our slope is going to be opposite of that to the regular function. There we go. Again, like I said, it's a little bit of a rough graph, but the general takeaways from graphing both of these functions is, first off, these graphs are perfect reflections, even though it doesn't look that way on the graph. They are perfect reflections of each other. What that means is that every y value for f of x is the opposite sign of that for the negation of the function. So if we even just taking like off the y-axis, we have 5 here in the y direction, and then negative 5 down here. So always keep that in mind every time that you're working with regular functions and then the negation of that function. In future sections of this course, you will be looking at like transformations of functions and reflections. So this is a really good kind of primer to that to get you set up for success in that future section. Now we're going to go ahead and graph the g of x equation. So we have our y-intercept of 4. So 1, 2, 3, 4. And then we're going to draw a parabola like that because it's x squared and not regular x. And then we'll graph the negation of that. So we have -4, so 1, 2, 3, 4. And then because it's a negative, x squared is going to concave down. Perfect. And again, it's the same exact concept. So every y value for positive g of x is going to be negative for negative g of x. So hopefully that was a really good kind of explanation for how to apply a negation to a function. If you have any questions for any other concepts in your class, feel free to visit tutoring.asu.edu. On there, we have the locations and also hours of operations for all of our tutoring centers on the ASU campuses. We're on all 4 ASU campuses, as well as having an online tutoring center as well. So feel free to check us out. It is free for all ASU students. If you enjoyed this kind of concept session video, go ahead and check out that other link on your screen. That'll direct you to a document that lists out all of the different concept session videos for this course that you can go to on your own convenience. But other than that, I hope you have a great rest of your day and good luck in your course.